All right, this is lesson 8.5 about YouTube. Let's dive in here. It says a random sample of 30 students. So that's N. Before we get too far down the road, that's N. Revealed a mean viewing time of 25.3 minutes with a standard deviation of S sub x 14.8 minutes. So a couple things here. This is the part in the chapter where we start doing means, which are x bars, right? Right as it says right there. And the standard deviation is 14.8. So if you have your cheat sheet out, this is where we now start to do the right side. You can take time, you can fill this whole thing in, but I'm going to kind of cover most of these things in this lesson, okay? Okay, we're going to make a 95% confidence interval to estimate the true mean daily YouTubing time for all students. The point estimate is always, again, remember this is going to be the center of our interval. Today that's going to be x bar. So 25.3 minutes. The population is just all students, because it just is kind of a generic students. The parameter is mu, which is in words now, which is well, you could always look for it, folks. It's right here. This is the parameter in words. And it's worth your time, I think, to write it out. It is the mean daily YouTube viewing time for students. All right, the sample size is just 30. And the statistic, again, that's x bar, which is 25.3. Okay. The first couple questions here are getting into conditions. Just like earlier in the chapter, the sample must be random. Was it random? Yes, it says random right here. Woo, random. It's important because if we want to project our results onto the entire population of all students, the sample has to be random, and it has to accurately represent the entire population. Number 4, would it be appropriate to use the normal distribution? Well, since we're doing means, we need to check the CLT. So I look at the sample size. The sample size was exactly 30. N equals 30. So we just barely made it. Remember, the CLT is that it has to be 30 or greater. Therefore, the distribution we're working with is approximately normal. It doesn't say it here. There's no number for independence, but you should check independence as well. Yeah, I put that lower down here. Your conditions are always random, normal, and then independence. But it would satisfy it. Because 30 is far less than 10% of all the students in a school. Number 5, what is the standard deviation of the sampling distribution for x bar? So this formula is what we had last chapter. You take your sigma and divide by the square root of the sample size. However, right now, if you look up here, we were not given a sigma. There's nowhere up here that it says how the population is distributed. So I'm going to use this instead. I'm going to use the sample standard deviation. So for this, I'm going to say, we're going to do S sub x instead. It's going to be like that. Well, I'll leave it. I'll just change the one on the right. So on your cheat sheet, just to kind of make connections again, I'm down here. Okay, it's S sub x because I don't know sigma, okay? So since it came from a sample, I'm also going to cross that off and say SE. So that's the formula that's on your cheat sheet. So what do we have when I plug in the numbers today? I have S sub x was 14.8. Sample size was 30. I'm just grabbing my calculator. I should have had this ready ahead of time. And I get 2.702. Okay, there's my standard error or my standard deviation of the curve. All right, here's a big concept. When we're going to find the margin of error for a confidence interval, when we're doing proportions, we had z-stars. Remember that on the critical values on the formula sheet, we had z-stars. This is the number of standard deviations necessary to achieve these percentages, right? Now we're going to use t-stars, and we have to look these up in a table in your green packet. So get your green packets handy, okay? And let me explain it. So we use t-stars, not z-stars. So why? What's going on? It's because it's kind of related to the CLT. As your sample size gets bigger, the CLT says that as it gets bigger and bigger, you become more and more normally distributed. So this purple curve is like for a small sample size. As your sample size grows, this purple curve would get a little steeper. And then if it grows again, it would get even steeper in the middle. And eventually it would map right on top of this normal curve. The N is for the normal curve. So we kind of have a sliding scale here, essentially, of how, based on our sample size, how well does the t distribution fit the normal curve? And there's a new term called degrees of freedom, which is df, okay? It is easy to calculate. It's just n minus 1. So your sample size is 30. When you subtract 1, you get 29. We look up our critical values in table B using the degrees of freedom. So there's no like set list for this. You always have to look up your t-star in your green packet. So I'm going to keep in mind 29, and I'm also going to keep in mind 95%. Okay. So to my College Board sheet, scroll to almost the back. This is the second to the last page. This is not Table A. Table A is for z-scores. See that? It's not that one. This is the second Table A. That's for z-scores, so it's not this one. It is this one, Table B, which says t distributions, okay? And notice, what does it say right over here? df. So there's degrees of freedom. Okay, and what we had was 29. So I'm going to go down to the 29 row and highlight the whole row. Which one do I want? I want the one that lines up with 95%. So where do these two intersect? They intersect at 2.045. So for this question, that is my critical value. Okay? 2.045. Little side note, right? Like I was saying earlier, this curve, as the sample size grows, this curve will become more and more like the normal curve. The t curve, the purple curve, will become mapped right on top of the normal curve. And you can see this in this College Board packet in a way, right? So here, degrees of freedom is really based on sample size, right? It was just 30 minus 1. That's how I got the 29. So these are really increasing in sample size as you go down, right? So here are the t-stars for 95% confidence, right? Look at what's happening. As my sample size is really small, my t-stars are really quite big. I mean, the first one's 12. But then as I go down the table, as my sample size grows, n is getting bigger, right? As n gets bigger, what is happening to these t-stars? They are getting like, 2.1, 2.0, 2.0, they are getting closer and closer to what? What's on the very bottom? The very bottom is Z star, right? Remember, the bottom row is my Z star row. So this is logical, right? We know as sample size grows, the curve becomes more and more normally distributed. So if you could increase your sample size forever to infinity, your T stars would become Z stars. So that's kind of a cool thought. All right, so got that. Here's a explanation if you're like, what the heck is degrees of freedom? Why is it n-1? It's kind of not necessary to understand this for the class, but this is for those of you thinkers out there that are like, I want to know. All right, so we're going to get the margin of error next. For proportions, it was this, right? For proportions, we had a Z star. What do we have now? We have a T star. And for proportions, this was our standard error. What do we have now? We have S sub x over the square root of n. So in many ways, the margin of error formula is much smaller. And again, it's on your formula sheet right here. Okay, so let's build the interval. Find the 95% interval using point estimate plus or minus margin of error. The point estimate is x bar, and the margin of error we just found, right? It's all of this. So that's what I want to do. I know my point estimate. It's 25.3. That's from way up at the very beginning. Plus or minus, let's actually calculate this up here. What is the margin of error? Let's put a number to it. So my T star was right here, 2.045. And my standard error was 2.702. Standard deviation, standard error, same thing. Okay. 2.702, which is I'm just doing this on my handheld calculator here. 5.53. So that goes down here. That's my margin of error. If you're a visual person with your number lines, here's what we got. We know the middle is 25.3. I know I'm going plus 5.53 and minus 5.53 to get the endpoints, to get my interval. And so what is that? 25.3. 25.3 plus 5.53. That's the high end of the interval, 30.83. And then copy and paste and just make it a minus, 19.77. Okay, so there's my interval, folks. We are, what was our percent confidence? We're 95% confident that the interval from 19.77 to 30.83 captures the what? This is the parameter. I'm going to be smart here. I don't want to write it again. So I'm going to copy it from up here, from the parameter. Just duplicate it and bring it down. Oh, that didn't work very well. Come on. There we go. Just put that in there. Okay? So there it is. There's your first interval. Your first interval for a sample mean. So here's the summary. Most of this is on your cheat sheet, okay? The main differences are we use T stars for means, which is based on a new term called degrees of freedom, okay? You got to look it up in table B. And the margin of error idea is the same, but the formula is now this. All right, folks. Thank you.